The world seems fixed, but it's an illusion. Beneath our feet, the Earth is in constant motion, a dynamic dance that has been ongoing for billions of years. This movement is not something we can see in our daily lives, but it is a powerful force that shapes the very surface of our planet. Continents are massive rafts of rock, floating on a sea of softer rock. This softer layer, known as the mantle, is in a state of slow, convective motion, causing the continents to drift. This process, known as plate tectonics, is responsible for the ever-changing face of our planet. This movement is slow, yet over millions of years it reshapes the planet. The landscapes we see today are the result of this gradual but relentless movement. Mountains rise, oceans widen, and coastlines erode, all due to the shifting of tectonic plates. South America is on a westward journey, shaping its past, present, and future. As it moves, it collides with other plates, giving rise to the majestic Andes Mountains. This journey is not just a geological phenomenon, it is a story of transformation and evolution. Understanding this movement explains similar fossils on different continents. Millions of years ago, South America and Africa were part of a supercontinent called Gondwana. As they drifted apart, they carried with them the same species now fossilized, providing evidence of their shared history, and the occurrence of earthquakes and volcanoes. These natural events are direct results of tectonic activity. As plates move, they interact in ways that can cause the ground to shake or molten rock to erupt from the Earth's crust. These geological forces have been at work for billions of years, creating the world we know. The ancient mountain ranges and vast geological features we see today are monuments to the Earth's dynamic history. By studying South America's movement, we glimpse these powerful processes. Geologists and scientists dedicate their lives to understanding these movements, piecing together the puzzle of our planet's past and predicting its future. The planet is a dynamic system of constant change. Weather patterns, river courses, and landscapes are all influenced by the underlying tectonic activity. This constant change is a reminder of the Earth's vitality and resilience. We'll explore South America's journey from its connection with Africa to its future possibilities. Will it continue west, collide with another landmass, or perhaps even break apart? The possibilities are endless, and each scenario holds the potential to reshape the world as we know it. And what will these changes mean? The future of our planet is as dynamic as its past. As continents continue to drift, new landscapes will emerge, and with them, new ecosystems and climates. These changes will have profound impacts on life on Earth. The story of South America's movement is the story of our planet's deep history and its far future. It is a testament to the power of natural forces and a reminder of the ever-changing nature of our world. As we look to the future, we are reminded that the Earth is not a static entity, but a living, breathing planet in motion. Imagine traveling back in time, 200 million years ago, to a world that looked nothing like the one we know today. Back then, all of Earth's landmasses were joined together, forming a single gigantic supercontinent known as Pangaea. This colossal landmass stretched across much of the planet, surrounded by a vast global ocean. The climate, the landscapes, and even the life forms were dramatically different, shaped by the unique conditions of this ancient world. Pangaea was the starting point for a journey that would forever change the face of our planet. If you look closely at a map today, you might notice something remarkable. The coastlines of South America and Africa seem to fit together almost perfectly, like two pieces of a giant jigsaw puzzle. This isn't just a coincidence. Millions of years ago, these two continents were literally connected, sharing borders, landscapes, and even ecosystems. Their snug fit is a visible reminder of their ancient bond, a clue left behind by the forces that once held them together. Over countless millennia, powerful geological forces deep within the Earth began to pull Pangaea apart. This slow but relentless process, known as continental drift, gradually separated the landmasses. As the continents moved away from each other, a vast expanse of water, the Atlantic Ocean, began to form between them. What started as a narrow rift eventually became one of the world's largest oceans, forever dividing the lands that were once united. The separation began with a rift, a deep crack in the Earth's crust. Over millions of years, this rift widened, and water from the surrounding ocean slowly poured in, filling the gap and creating a new sea. This was not a sudden event, but a gradual transformation, shaped by the immense power of tectonic forces and the steady flow of water. The birth of the Atlantic Ocean was a monumental chapter in Earth's history. This entire process is known as continental rifting. It's driven by the movement of tectonic plates, massive slabs of rock that make up the Earth's surface. As these plates slowly drift apart, they reshape continents, create new oceans, and even trigger earthquakes and volcanic eruptions. The rifting that separated South America and Africa is just one example of the dynamic forces that continue to shape our planet today. Scientists have uncovered remarkable evidence of this shared past. Geologists have found identical rock formations and matching layers of sediment on both sides of the Atlantic. Even more astonishing, fossils of the same ancient plants and animals have been discovered in both South America and Africa. These discoveries prove that the continents were once joined, supporting the theory of continental drift and revealing the deep connections that link our world. As the continents drifted apart, they each embarked on their own unique evolutionary journeys. The separation created new environments and climates, from the lush rainforests of the Amazon to the vast savannas of Africa. Over time, these changing landscapes gave rise to a dazzling array of plants and animals, each adapted to their own corner of the world. The split not only shaped the land, but also the incredible diversity of life that we see today. The great drifting apart of South America and Africa was more than just a geological event. It was a turning point in the story of life on Earth. By creating new continents, oceans, and habitats, it set the stage for the evolution of countless species and the emergence of the rich, vibrant ecosystems we know today. The legacy of this ancient separation lives on, written in the rocks, the fossils, and the living creatures that inhabit both continents. To truly understand how South America moves and changes over time, we need to look deep inside our planet. The story of continents shifting and mountains rising begins far beneath our feet, in the hidden layers of the Earth. Imagine peeling back the surface of the planet, revealing a complex world of rock, heat, and constant motion. This is where the journey of tectonic plates begins, a journey that has shaped the face of our world for billions of years. The Earth's outermost layer, known as the lithosphere, is not a single unbroken shell. Instead, it is fractured into massive pieces called tectonic plates. These plates fit together like a giant, ever-shifting jigsaw puzzle. One of these is the South American plate, which carries the entire continent of South America and part of the Atlantic Ocean floor. All around the globe, there are about a dozen major plates and several smaller ones, each moving in its own direction, interacting with its neighbors in a slow but relentless dance. These tectonic plates are not fixed in place. They float atop the semi-molten, flexible layer beneath the crust called the asthenosphere. The asthenosphere is made of hot, slowly flowing rock, heated by energy from the Earth's core. This heat causes the material to move in swirling patterns, much like thick soup bubbling on a stove. The plates above are carried along by these powerful currents, which act as a conveyor belt, moving continents and oceans over millions of years. Deep within the mantle, convection currents are constantly at work. These currents are created as hot material rises from the deep mantle, cools near the surface, and then sinks again. This cycle of rising and falling rock generates immense forces that push and pull the tectonic plates in different directions. Over time, these movements drive the process known as continental drift, slowly but surely changing the positions of continents and reshaping the face of the Earth. Although tectonic plates move at a pace that seems almost imperceptible, about as fast as your fingernails grow, just a few centimeters each year, their impact is enormous. Over millions of years, these tiny movements add up, causing continents to drift apart, collide, or slide past one another. This gradual motion is responsible for the formation of mountains, the opening and closing of oceans, and even the triggering of earthquakes and volcanic eruptions. The edges where tectonic plates meet are called plate boundaries. These boundaries are dynamic zones where the plates interact in different ways. Some boundaries see plates moving away from each other, others have plates crashing together, and some slide side by side. Each type of boundary creates unique geological features and is a hotspot for dramatic Earth processes like earthquakes, volcanic eruptions, and the building of mountain ranges. One of the most fascinating examples of a plate boundary is the Mid-Atlantic Ridge. This underwater mountain range is a divergent boundary, where the South American plate is moving away from the African plate. Here, magma rises from deep within the Earth, creating new ocean floor as it cools and solidifies. This process slowly pushes the South American continent westward, expanding the Atlantic Ocean and reshaping the map of the world. At convergent boundaries, plates move toward each other and collide. This is happening along the western edge of South America, where the South American plate meets the Nazca plate. The immense pressure from this collision forces the land upward, creating the towering Andes Mountains. These boundaries are not only responsible for mountain building, but also for some of the world's most powerful earthquakes and volcanic eruptions. The way plates interact at their boundaries, whether they are pulling apart, crashing together, or sliding past, determines the direction and speed of each plate's movement. These interactions shape the landscape, influence natural disasters, and even affect the climate over millions of years. By studying tectonic plates and their boundaries, we gain a deeper understanding of the powerful forces that continue to shape our planet today. The westward push from the Mid-Atlantic Ridge is only half the story. On its western edge, the South American plate collides with the Nazca Plate. The denser Nazca Plate subducts beneath the South American plate, a powerful geological force. Subduction creates the Andes Mountains and causes earthquakes along the coast. The process reshapes the continent, lifting the Andes and pulling the South American plate westward. This geological tug-of-war ensures South America's journey will continue for millions of years. South America's western edge is part of the Pacific Ring of Fire. This zone is known for intense volcanic and seismic activity. The Andes Mountains, a result of subduction, create diverse environments and shape the climate. The Ring of Fire brings both risk and resources, with mineral wealth and natural disasters. The geological forces shape the land and the lives of the people who live there. South America's movement won't stop, and scientists predict future tectonic shifts. One theory suggests the Atlantic Ocean will widen and the Pacific will shrink, forming a new supercontinent, Amasia. Another possibility is the Atlantic Ocean shrinking, leading to a new supercontinent, Pangaea Ultima. These scenarios show the continents will continue to move, reshaping the world map. The movement of continents has huge consequences for life on Earth. South America's isolation allowed unique evolution, but the Great American Biotic Interchange changed that. North American species outcompeted many native South American animals. Future collisions could trigger massive competition and extinction, reshaping ecosystems. South America's movement affects societies, economies, and politics. The Andes Mountains are a barrier to trade but also a source of mineral wealth. Living on an active plate boundary has economic costs, with earthquakes and volcanic eruptions posing risks. Geological changes affect ocean currents, climate patterns, and global trade. South America's movement reminds us the world is dynamic and ever-changing. Understanding plate tectonics explains the distribution of continents, resources, and life. The journey of South America connects deep Earth processes to surface life. The slow drift of a continent has real effects on the world today, and will shape the future. The forces that move continents are beyond our control, but understanding them helps us prepare for challenges. The world is moving, and we are moving with it.